Math marbles, there are tons of properties that have to do with exponents. Well, not tons, but there are about 6 that we always work on, and I'm going to look at the first 2 with you, and I'm going to try and answer a big question of why. When I learned about the zero exponent property and the negative exponent property, I was just told do this and just keep repeating it. So for example, anything to the 0 power is just equal to 1. As long as a is not equal to 0. Because you can't have 0 to the 0 power is equal to 1. That doesn't exist. Doesn't make sense. So if I had 2 to the 0 power, I would just have 1. If I had 15 to the 0 power, I had 1. If I had 2 million to the 0 power, it would still be 1. Didn't know why. I just followed the rule. Okay, anything to the 0 power is 1. And then there was a negative exponent power. So for example, a to the negative n. And they told us, well, you're going to rewrite this as a fraction, 1 over a to the nth power. So for example, 3 to the negative 3rd power would just be 1 over 3 to the 3rd power, which simplifies to just 1 over 27. And again, I can replicate this. I can just look at it and say, you want me to do that? Okay, I'll do that. Nice and easy. I don't know why it works, but I will do it. But then I started to ask questions. I wanted to know why this works. And so I thought about it for a while. I didn't want to just show you something and tell you do what I do and say what I say and just trust me. So I wanted to look for a pattern that can make it make sense. So watch what I'm going to do here, Math Marbles. I'm going to show you a pattern. Here's 3 to the 4th, 3 to the 3rd, and they're going to descend. My exponents will descend. 3 to the 2nd, 3 to the 1st. And we're going to use this to figure out 3 to the 0, 3 to the negative 1, and 3 to the negative 2. So let's look here. So if I wanted 3 to the 4th power, I would rewrite it as 3 times 3 times 3 times 3, which is the same as 81. 3 to the 3rd power is just 3 times 3 times 3, which was equal to 27. To the 2nd power is just 3 times 3, which was equal to 9. And 3 to the 1st power is just a 3, which is equal to 3. So let's pause for a minute and look for sequences. I'm just going to write this pattern, what I see happening. 81, 27, 9, 3. I notice that these numbers are all decreasing, but are they decreasing in the same way? Yes, they are. Each time my numbers are decreasing, they're being divided by 3. And this makes sense because when I expanded, I had 4 3s. Now I have 3 3s, 2, and 1. So thinking about this with our numbers, each time they're being divided, I see a pattern of divide by 3. So if I were to continue that pattern, as I'm looking at it here, what would the next number in the sequence be? If we're continuing the pattern, divide by 3 each time, that's our base, divide by 3. Then my next number, it just makes sense, would be 1. Because 3 divided by 3 would make 1. So think about that for a second, Math Marbles. I'm just taking that number and I'm just doing 3 divided by 3. And that's just going to give me 1. So what would the next number in the sequence be? I have 1 and I'm going to divide it by 3 again. So 1 divided by 3 is 1/3. And here, so you can see right here why this zero property law exists. It's just following that pattern where my exponents are decreasing each time. And as I'm decreasing each time, I'm dividing my number by 3, dividing it by the base. And you can see here, once I get to 1, I'm going to continue that pattern. I'm going to divide by 3 again, which is the same as 1/3. which is just the rule we talked about with the exponent property. So I'm going to do it one more time, and I'm going to go to the negative second power. So 1/3 divided by 3. I'm going to give you some space over here. 1/3 divided by 3. So we keep the first one, change its multiplication, and we're going to multiply by the reciprocal, which is 1/3. So look at that, math marbles. This is the same as 1/3 times 1/3, or 1/3 to the second power. You can see it. And so that pattern continues. So math marbles, this is, again, it's something that I don't think is always intuitive. We can't always understand why, but if you look for sequences and patterns in numbers, you can see amazing things. And this was something that was recognized and developed into the zero exponent property rule. So they notice that when you get to the first, any number to that first power, we know that for the next one, we're going to divide by the base. So any number I have to the first power, for the next one, I'm going to divide by that base, and that's just going to give me 1. And then to get to the negatives, I'm going to continue starting from 1, dividing by that base. So 1 divided by 3. And dividing by that base again, divide by 3, divide by 3, and that pattern will continue. So my next number is going to be 1/27. And the next number will be 1/81. So you'll see this pattern happening. 27, 1/27. The next one's 81, 1/81. So I'm going to stop right there, math marbles. And as I'm making more videos about exponents for 8th graders, I'm going to look for more real patterns and solutions to help us explain why these things actually happen and how these rules came to be. I'll see you in the next one, math marbles. Take care.